All right, welcome back to the channel. Today we got a little project, some parts that a coworker had. I believe this is machined out of ABS. Well, this guy has a little lip, and it has to fit inside of an aluminum part that was 3D printed in China as well. But they didn't print the little slot deep enough for this to seat in. So we're gonna pick up a location and machine a slot. Okay guys, here's the part, and you can see this slot right, or this little boss that sticks out, this channel that sticks out. This has to go in the aluminum part. So I've got this step file that he submitted for 3D printing, and that right there is what we have to cut. Here's a little setup I came up with, my small vise. I'm going to go ahead and put this in the big vise, kind of like this. I've got a gauge pin fit into this hole, very tight fit in this hole, very precise. So what we'll do is we'll sweep the diameter of this, and that will become my 0. Touch off on the height, that will also become Z0, and we should just be able to run a very small tool through that little channel and get that to the proper depth. Here's a pretty good view of the depth of what was 3D printed versus kind of what we need. Finger in there for scale relationship. So yeah, let's get this thing in the machine and try and sweep this this pin and let that become 0. Okay, so we got the vise in the vise, and I've done a little sweep of this pin, and I've got her within a half thou. That should be just fine for what this is, a 3D printed part, plastic into aluminum. You know, when they 3D print aluminum, there is also this real wild shrinkage. They print the part a certain percentage oversized, and then it's oven cured essentially, and it shrinks down to a given percentage. So I could put 2 pins in, measure, see how close it all is, but I think for what this is, I think if we just locate this pin, come in and cut this slot, we're going to be just fine. Okay, there's a good view of the end mill we're going to use. Looks like it's a 4 flute. I've rolled it around. The corners look pretty good. When these things get this small, this is kind of how we have to look at them to make sure that they're going to perform. And here you go. This is a 1/32 end mill. Alright, we got the part sitting on parallels located in here. Of course, I took the parallels out, they're just too big. But when we clamped this down, it was very level, sitting on parallels. So what I'm going to do, I don't want to touch the surface of this part, so I'm going to use the old school method. We're going to stick a piece of copy paper in there, and we're going to come down in 1 thou increments until that tightens up. Click, 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 click. Keep going down until it's dragging, coming down. Right there, locked it up. So I'm going to go up 1, get it out. Now I know that this is about 4.5 thou away from the part. So I'm going to come down 1, 2, 3, we'll go 4, right there. That is not touching the surface, and for what we're doing here, which is going to be fussy. We're going to do many programs to dial this in just right. That is going to be close enough. So we come up here, we're going to change Z to 0. Boom. All right, like you can see right up here, I've got the origin for X and Y set at the center of the hole. And we've got a tool path made. This is just a simple contour. And I've got a tool called out as a 1/32 flat end mill. If I zoom in, get off the part there, you can see that the slot is bigger than the 1/32 end mill, so I have a contour built all around the bottom of that channel. And if I do a little back plot right here, there's the tool, and if I run the back plot, there's the cleanup. All right, so this should get us in the neighborhood. So what we're going to do next is generate our G-code. So up here, you can see where my cursor's at up here. I will just click on this little G1, accept it. I'm going to save it off to my designated file location. Code Expert opens up, and boom, there's my G-code. So I'm going to check, I've got coolant right here. Here's my M8. Feeds look correct. The heights look correct. So we're just going to save it off to the machine. Save as. Here, I'm going to save it as a text file, and I'm just going to call it the name of this part. And keep it simple, 1, and save. Boom. My old machine, I have added a solid state drive, so all this process goes much faster. I also added an Ethernet card, which was not common back in the day of that machine, 1999. Okay, the program is in memory. We have to bring it into the CNC controls, so program transfer, transfer in, and we're going to browse to that location and just scroll down until we find that guy. There it is right there. And okay, start the transfer. Boom. And we're going to run this program. And that's it. We're all set up. Scroll down to make sure everything looks good. We've got some coolant going there, M8. Z heights look correct. Should be good. I like to-go display. So there we go. Now we can see as the tool comes down, you gotta make sure it's not gonna crash. Never crashed the machine yet. Okay, that's 6,000 RPM, 6 inches a minute. And we're only taking, the step downs are, I think I'm doing 10 thou cuts. Pretty safe. All right, this should be final depth at about 88 thou deep. Now, of course, no matter the shrinkage rate of this, if that was off at all, doesn't matter. this piece was machined out of ABS. So now that we machined this slot for that to lock into, should work perfectly. Well, let's see how we fit. Of course, the alignment's got to be just right. There she goes. Perfect fit. Perfect. I mean, there's no slop in that at all. All right, we got one more thing we got to do to this. Here's our fit up. Turned out nice. What we have to do is this deep pocket right here, the deepest pocket, what we have to do is take this sheet of clear polycarb, 60 thou thick, and we have to make a little window to go in there. And I'll show you how I do that. Okay, the first thing we got to do is measure, get an idea how big we need to make this window. Don't have a drawing on this guy. So I'm going to say about 170 thou by, I'll make sure we get the correct ledge here. Okay, there we go. By like, let's say 515. That should be enough clearance. So 170 thou by 515. So all I'm going to do is just write that right on the sheet. 170 by 0.515. All right, that's a wet erase fine point marker. And off to the bandsaw. All right, we just got to cut us a little piece here. Probably just going to make it square-ish. And then, yeah. Let's come over to this side. One of the reasons that polycarb is so cool, you can see it's just joined by a little bit right there. It's very durable. There we go. 60 thou thick. Let's cut it to that size. Okay, so we've removed the protective wrap on the polycarbonate here. Got double-faced tape, got it stuck down to a piece of aluminum, obviously, and this is a 1/16 end mill, and I've taken a cut over here on this side. So now what we're going to do is on the X, we're going to go ahead and move that 1/16 of an inch. Right there, and reset that at 0. Now we can come over the width of the part, which was 515. You know, pretty close. Probably going to go a little wide and do a cleanup pass. So there it is. Now we'll just make that cut, and that will bring it one side to size. Okay, now we do the exact same thing in the Y. So across the top of this guy, I'll make a pass. Back and forth. Okay. And what we'll do is reset Y to 0 and move it. The direction's correct right there. I'll just move close enough. And then we remember the other direction, it was 170. A little big, make a cleanup pass. Alright, now all that's left is to get the piece off. The double-sided tape doesn't leave a lot of residue. And we just need to do a little hand deburring, and this piece will be ready to go. A little bit of deburring, and here's our part. It's pretty darn good. And let's see, it is right there. So 169, 170 was our target. And then in this direction, .515, 518 will fit just fine. Should anyways. All right, so there's a great example of at least my process of how I go ahead and make these tiny little pieces. You can see that guy kind of shining in there. There he is. The window's in, and it's held in, doesn't fall out. Yet it's not bonded in there, so we got a great fit on that piece. And then the other thing we did was, you know, locate this really strange shaped thing, and then cut that little slot, that real irregular shaped slot in there. We went 88 thou deep, and what that did was it allowed the two pieces to fit together. Beautiful. Great fit. There's no slop in that whatsoever. It's a perfect fit. So yeah, there you go. Fun little project, little side work for one of my coworkers. Don't know what this does. Kind of top secret, but you know, maybe one day we'll all find out what this does, and it'll be a game changer. Who knows? But yeah. So there's a little fun project, and stay tuned. Like, subscribe, share, and more content coming.